Okay, we're going to take a look at what square roots are and what cube roots are. So let's start with square roots first. And you can tell here I've got a picture of a Cheez-It. And we can tell that a Cheez-It measures one side is 1 and one side is 1 as well. So if we were to build the next size up of Cheez-Its, so here I have one Cheez-It. If I take a second Cheez-It and I put it next to it, it's going to give me a rectangle. And what we want to do is we want to be able to build the next size square. So if I take another one here, that will give me 3. And we can see that it takes 4 to get me the next size square up. So what we're going to do is we're going to kind of keep track of it on this paper where it says number of squares. I'm going to say 1. And the next number of Cheez-Its that's going to help us to make a square is 4. So using this idea and using this idea of Cheez-Its, we're going to keep on grabbing Cheez-Its to build another one. If I go to build another one, again, if I add them 2 at a time, that's only going to get me to be a 6, and that's still a rectangle. So we still want to make a square because we know what a square is. A square has equal sides measurements. So we can see now that this one has a side measurement of 3 and a side measurement of 3, and altogether that'll give us 9. So we're going to record 9. We'll do this one more time, again taking these. And if I just put one more row on, we can see that it turns out to be just a rectangle again. In order to be a square, which means both sides need to be measured this exact same, we're going to have to put 4 more down. Okay, and again, now we have what we call a 4 by 4, so that would be 16 squares. Now, we're going to talk about what a root is. We know what a square is. We just talked about squares, and we've got that going. But let's talk about what a root is. So let's first take our 3 by 3 Cheez-It square here, and let's draw this in this little square here to kind of get an idea of dimensions. So we know that these are 9, and we can see that this side here measures 3, and this side here measures 3. So when we talk about a square, we know that both sides have to equal the same thing. But when we talk about a root, what the root is going to represent is the root's going to represent the side dimension. The side dimension of the square. So when we think about what a square root is, we want to think about, if I built a square with that many pieces, what would the root be? What would be the side measurement? So let me go back to our table. If we think about that, if we had that 1 Cheez-It, we know that the side was 1. When we had 4 Cheez-Its, we know the side measured 2. 9 Cheez-Its, 3, and 16 Cheez-Its, 4. But we can see how this pattern is going to continue, 5, 6, 7, 8, 9, and 10. And we can do the same thing all the way up to 20. And now we don't really have to use Cheez-Its to continue this. We could use some knowledge. We can borrow some knowledge here and put. Okay, so let's continue and let's fill in this chart. 5 times 5, 25, because we can see now that's the pattern, because the side measurement is just taking this number and multiplying it by itself. 4 times 4 is 16, 3 times 3 is 9. We can continue and fill out the rest of this table and get all the numbers down. Some people might not be able to continue this without a calculator. 16 times 16 gets us 256. 17 times 17 will get us 289. 18 times 18 gets us 324. And 19 times 19 is going to give us 361. And 20 times 20 is 400. So this gives us an idea about numbers and their relationship. So if we were to kind of set this up on a number line, these numbers 1, 2, 3, and rising, so 1, 2, 3, 4, 5, 6, 7, 8, I'm going to go up to 12 here, or 13, just for our discussion. And if we take the number that's opposite, that's number of squares, 1, 4, 9, 16, 25. And we take a look at these numbers and evaluate them. Now we know that maybe 1 may be equal to 1, but 2 doesn't equal 4. So we're going to use this thing here called a root bar or a radical sign. It looks like this. And what that does is if we put it over these numbers of our total number of Cheez-Its or our total number of individual squares to make larger squares, that's telling us that, hey, take the root of this many pieces. Take a side measurement of this many pieces, and where do you end up? So the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and so on. So that kind of gives us a better idea of what the word square root comes from. So now let's talk about cube root. And here I have a picture of a unifix cube. And unfortunately, my unifix cubes aren't going to stack up as pretty as those other ones are. So we're going to have to use a little bit of imagination here with us. Okay, so we know that 1 is going to represent 1 by 1 by 1. So now we're kind of working what we call 3 dimensions. That Cheez-It was a 2-dimension. It was flat. This is more of a 3-dimensional thing. And we can see that even if I was to take 4, I'm only getting 2 going across this way and 2 going this way, but it's only 1 deep. I'm going to need to put some more in front or behind it. Let me do it this way. They're going to have to team up a little bit like this. And I know it's hard to see with me doing it this way with these cubes, but get you the idea that it is 2 deep, 2 in front, and 2 high. Because now we have depth involved. So we're getting 2 by 2 by 2. So if we were to draw it on our little cube here, we would have 2 high, 2 deep, 2 wide. And we can see that it takes 8 cubes to get there, right? So let's go to our table again. So when we had 1 cube, we know that the height and everything was 1. But when we wanted to get 2 high, we wanted the root to be 2, that measurement to be 2, it took us 8 squares to get there. So again, we know what a cube is because it's 3-dimensional, and our word of root, it's going to be the side dimension of a cube. So we're going to fill out this table and continue this idea. So if we have 3, 4, 5, 6, 7, 8, 9, and 10, again, 3, so we don't really have to build this, but if we did, I know it's kind of hard to do it with our cubes here, but we would add another row in front. We'd have to go 3 high and 3 deep. So now we're adding a whole other section to it, and we would end up with 27 of them. If we think about what this is 3 times 3 times 3. Okay? Because we're going in 3 dimensions. Before we're going in 2 dimensions, so we were just multiplying times 2. Now we're going in 3 dimensions, we're going to be multiplying times 3. So 4 times 4 times 4 is going to give us 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. 9 times 9 times 9 is 729. And 10 times 10 times 10 is going to give us 1,000. And just like we did with the, remember, this is a root symbol. But because we don't want to confuse it with square root and all the other roots, we'll put a 3 there. That'll tell us that it's a cube root. So if we were to build our cube roots over here, put a few of them down, we'd be able to drop numbers in. The cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. And we could go on, continue on. And we know that, remember, the root means a side dimension. So the side measurement. So this would kind of help us to understand that. I'm hoping that this lesson helps you to understand what cube roots are and what square roots are and where it comes from, and hopefully get a better, deeper meaning about it.